right. Welcome back, guys. We're going to continue our lesson with quadratics. And specifically, now we're going to solve quadratics by factoring. Our previous lesson, we were solving quadratics by graphing. Not the most efficient to do an XY table, figure out where the intercepts lie. But this is actually a really good technique if it can be factored. Now, think about what factoring means. Well, let's come up with a basic example. What about 12? Well, what kind of factors make up 12? Well, we could do what? 6 and 2. We could do 4 and 3. We could do 12 and 1. Okay? And we can include negatives in here to get the same result. But these are factors. Okay, that's great. What about quadratics? What would the factors be for this guy? What two numbers do I multiply together to get me this? The answer is there isn't any numbers. I can't just come up with two numbers with no x's involved, right? No variables. So that's telling me that my two numbers are going to have more than one term. It's going to be a binomial, right? It's going to be x plus or minus another number. When I multiply these two, they become factors of this guy. It gives me the original answer, just like 12, right? 6 and 2 are the two numbers that I multiply together that give me the number I'm looking for. Same thing here, except now I'm looking at two binomials. And when I multiply these two, I get that as my result. Okay, that's the goal, the central setup for today. Okay, now where does that fit in when it comes to finding answers? We'll get to that. Honest, we're going to get to that. It's coming. We're just going to leave that as a cliffhanger right now. Okay, let's look at the zero product property. For any real number, a and b, okay, if a, b equals 0, then a or b has to be 0. Look at that statement. That makes sense, though, doesn't it? If both of these numbers multiplied together gives me 0, one of them has to be 0 for that to be true. Let's expand upon that. Instead of looking at a single number, let's look at an expression. Look at this guy. Okay, this first one's x plus 3. This second binomial is x minus 5. When I multiply these two, I get 0. What numbers, if I plug into that, will give me that? Well, let's think about it. Either this part is going to give me 0, which I'm going to figure that out. Wouldn't that be a negative 3, right? Or this part has to be 0, which for that to happen, I have to have 5, right? Therefore, what I could do to solve it, I mean, you could just see it mentally, but if not, you could set each one equal to 0 to figure out which one of these will give me that result. Okay? Does that make sense? Do you guys see that? If I multiply these two, don't I get a quadratic? Yeah, I do. If I distribute, I'm going to see that quadratic. What we're doing is we're using factors to actually see what the solutions are to my quadratic. We're using its factors. Now, we haven't figured out how to find the factors yet. We're getting there. All right? So we're going to take a look at our first example. And I don't need this no more. Goodbye. So long. All right? Let me just exit out of this PowerPoint real quick. There we go. Okay, adjust the camera. You guys can see then. So our first example is going to be 9y squared plus 3y equals 0. And we're going to find numbers that give me that. And the way we're going to do it is we're going to factor out a GCF, a greatest common factor. Okay? So what we're going to do first, look at the coefficients, 9 and 3. What's a factor that 9 and 3 both have in common? The answer would be a 3. Now let's look at the y's. We have a y squared and a y. What would be a common factor there? Well, let me reword that. How many y's could I take away? I think one. They both have one y. I can't take two y's away because this only has one to give up, right? So I could take one y out of it. Here's where most people start getting confused. I'm dividing both terms by 3y. That's me factoring it out, right? So this first term, if I factor out a 3, I'm left with a 3. If I factor out a y, I'm left with a y. Check your work. 3y times 3y gives me 9y squared. Over here, I'm taking a 3 out, so I'm left with a 1. I'm taking a y out, I'm left with a 1. So I'm done. 3y times 1 is 3y. If I multiply this out, I get the original. Okay, so there's my GCF. Now the zero product property states that either this guy becomes 0 or this guy becomes 0. Now, you could plug numbers in to figure that out, or set each one equal to 0 to find the y value that will do that. Okay, so 0 product property. That's what that is. Okay. All right. Now, divide both sides by 3. Y is just 0. You don't technically have to even divide by 3. So 0 will make this a 0, which would satisfy the equation. Take 1 to the other side. 3y equals negative 1. Divide both sides by 3. We get y to be negative a third. These two numbers will make this guy true. Okay? And we got there by factoring a GCF out. Okay? These are the factors of this guy. When I multiply these two, I get the original. Questions, thoughts, concerns, dilemmas? Hopefully not. Hopefully that was pretty straightforward. Okay, let's go ahead and try another one. And do I have space at the bottom? I think I do. Another example. So 5a squared minus 20a equals 0. Highly encourage you, pause the video, try it out for yourself. First, factor GCF. If possible, sometimes it isn't, but for these two examples it is. A 5 and a negative 20, I can factor a 5 out. That's what they have in common. A squared and 1a over there, I can only factor 1a out. That's all I'm allowed to factor. And when I do this, it's pretty much division. 5a squared divided by 5a is just a. That's the only thing I got left. If I multiply, I get the original. Okay, over here, negative 20, factor out a 5, you get a 4. They factor out, I'm done. Once again, 5a times negative 4 gives me negative 28. Here are my factors. Set each factor equal to 0 to find the a value that gives you 0. The first one's really just not even that, it's non-trivial, right? So it's just going to be a is 0. Over here, if I add 4, I get 4. So here are my two answers for this quadratic right here. And incidentally, remember, this is where it crosses the x-axis, right? Those are my answers. Essentially, we're taking its factors to get the answers for this guy. It's kind of cool, huh? Can you see a very vital step for solving this if you had a factor? It has to be equal to 0, right? If you don't get it equal to 0, you can't use that zero product property. Very important. Okay. Goodbye. So long. Farewell. New whiteboard. All right. Let's talk about another type of factoring that can come up. Let me just shift my notes around a little bit here. Okay. And we're going to call that perfect squares. And you're probably thinking, okay, what does that mean? So glad you asked. Okay. So let's talk about perfect square trinomials. Now, perfect square, we'll get to that part. Trinomial means there are three terms that we're looking at here. And usually in our standard quadratic format, there are three terms, okay? So here's the first one that we're going to talk about, the first example. X squared minus 6x, I think it's what, plus 9? Yeah. Equals 0. Now, what I'm going to do is I'm going to factor this guy, set each factor equal to 0, and solve for it. But this is a little bit different. Can I factor a GCF out? No, I can't do that. Darn it. What am I going to do? I can't just give up and go home. Don't you dare do that. Don't you stick around. Here's the trick. All right, and this is going to make more sense when we get to the answer. I'll work our way back up as to why this works. Look at the C value in this guy. It's 9. So here's the goal. You're going to come up with factors of 9 that when I add them up, I get negative 6. Okay, so I'm going to list some. We could do 9 and 1, 3 and 3, negative 3 and negative 3. Pause the video and vote. Sorry, I don't have any voting apparatus for that, but it'd be cool if you could, right? If you could vote for this. I think the bottom factors are going to work, right? They multiply together to give me 9. When I add them together, I get negative 6. Perfect. Okay. So that means my first is the variable, right? That's the first spot. The next spot are the two factors. They're both negative 3s. Hold on. Full disclaimer. If I multiply these factors up, if I multiply them, I get the original. So if you're ever unsure, are these correct? Well, do the multiplication. Okay. Now, by the zero product property, I could set each one equal to 0. Now, seems a little silly, but aren't these the same thing, right? Do I have to set each one equal to 0? No, because it's going to be the same answer. X just has to be a 3. Okay. Now, why do they call these a perfect square trinomial? Maybe you can see it. Hopefully you can see it. See how the factors are the same? They're identical, right? I could rewrite this. If I combine them, isn't that x minus 3 squared equals 0? In other words, this equation is the same thing as this, just written a little bit differently. All right? Hey, there's the square part, right? Perfect square. There we go. It's the same number. Excuse me. Just like 144, the square root of that is 12 times 12, right? Perfect squares. Same thing here, just with quadratics, which is kind of weird, huh? You wouldn't think that an expression could be a perfect square like a number is, but it can be. Okay, you guys kind of see that connection here? Now, what can we talk about visually? There's only one solution. What's that telling you about the quadratic? The vertex must be touching the x-axis. If we go back to a previous lesson, this is a transformation. Because the value is inside the parentheses, we're shifting this quadratic to the left or right. Since it's negative, we're going to the right by 3. So just doing like a quick sketch, my quadratic is looking like this. So therefore, I only have one solution. Okay? What do you think? Kind of cool, huh? We're using factors of a quadratic to solve it. Ah, it's fun stuff. Okay, let's try another one. Second example. I'm going to leave this up. Just take a different whiteboard. Okay. So another example about a perfect square trinomial. So x squared minus 16x plus 64. Okay. All right. Now the trick, like I said, is looking at this C value. So what are factors of 64 that when I add them together, I get the middle value, negative 16? Well, we could do 8 and 8, negative 8, negative 8. We can do 16 and 4. But I'm going to stop there. But I don't want to keep listing anymore. I think you can kind of see which factors I'm looking at. It's these guys, right? Negative 8 and negative 8. When I multiply, it gives me 64. When I add them, I get negative 16. So my first part of the binomial is just the x's, a's, b's, whatever the variable is. The second part are the two factors. We're going to set that equal to 0. And I apologize for not doing that in the original. That should be equal to 0 there. Okay. Now, these are the same, right? So we call that a perfect square trinomial. We know why now. We don't have to write this twice. We can just write it once. So if I add 8 to both sides, 8 would be my answer. So if I plug 8 into here, I'm going to get 0. That's one solution. Let's rewrite it. Isn't the same thing as x minus 8 squared equals 0? I can combine those two together. Same effect. It's a transformation. We're going to go to the 1, 2, 3, 4, 5, 6, 7, 8. We're going to go to the right 8. So my parabola looks like this. Rough sketch. I'm going to be very clear on that. So not only does factoring allow us to find solutions, it can also help us to graph it using some basic transformation ideas. Okay? So those are perfect square trinomials. Now, what if they're not perfect squares? Uh-oh. What does that entail? Well, it gets interesting. No, I'm joking. Actually, let me look at the time. We got 16 minutes. Yeah, we'll keep going. Okay. Let's look at non-perfect square trinomials. Let's get them into the picture. Okay? So let's title this next part in your notes, non-perfect square trinomials. Okay? We'll get some fun with it. Why not? Here's the deal. The process is actually the same. Okay? We're not going to change anything. We're still going to find factors of that c value that give me the middle term, which is the b value. Okay? So let me try another one. Let's do example, x squared minus 16x plus 64. Oh, no. I don't know if you guys are screaming at your computer. Mr. McCullough, we did that example already. You're right, we did. I apologize. Okay, so here we go. Factors of 15 that when I add them, I get negative 2. Well, let's start listing them. 5 and 3, negative 5, negative 3, right? What do you think? Anything up so far? Oh, I'm sorry. 2 mistakes. That should be a negative. Let's change that. There we go. Sorry about that. So negative 5 times 3 gives me this. Switch the negative around. I still get the same result. And out of these two, I'm thinking the first set of factors that I listed, if I add them together, I get negative 2. So this works. X squared by, my two binomials, the first value is going to be x. The second value are my factors. There we go. Okay. It does not matter, unlike a perfect square trinomial, it doesn't matter where you put this first. I could have put plus 3 here and negative 5 over there. It's still going to be the same. Okay. Can we pause the video? Time. Let's multiply these. I want to convince you of something here. So if I multiply x to both of these guys, I get x squared plus 3x. If I multiply both of these guys, I get negative 5x minus 15. If I combine these two, don't I get negative 2? Negative 15 and then x squared. See how you get the original? But look, you see how this is the factors over here? Do you see why we only look at the c value to figure this out? Hopefully that light bulb just went bing and went up like this, okay? That's pretty impressive, huh? That we can figure this out. Now, if this yields no result that works, then the quadratic just isn't factorable. Doesn't mean we can't solve it. You just can't solve it by factoring, unfortunately. Okay. Sorry about that. I just wanted to make that point. So let me erase my little multiplication lines, my arcs. All right. Next step, set each one equal to 0. Now, could you do that in your head? Absolutely. I'm just writing it out. Add 5 to the other side. X could be 5. Subtract 3 to the other side. X could be negative 3. And that's it. Pretty cool, huh? Same procedure as the first step, right? It's just, they're not perfect. All right? They're just not perfect. What do you think? We'll do one more? One more for the road? Maybe? Trying to find my notes. Trying to organize them a little bit. Oh, here we go. Here we go. Let's do one more example down here. And then that'll be it for part 1 of the video. There we go. Pause the video, see if you can factor this yourself. I want to find factors of 64, and when I add them together, I get 20. So 8 and 8 gives me that. 16 and 4 also give me that. So which one of those? Now there are more. I'm going to be very clear. There's a lot more here. Okay? I just stopped there because I can see it. It's going to be, what, 16 and 4? Because when I add them, I get 20. So if I'm going to set this up, my first spot for each binomial is an x. My second spot are just the factors I found. Doesn't matter which one's first. Next, using the zero product property, set each one equal to 0, just like that. The first one, I get x to be negative 16, and the other one, I get x to be negative 4. And I apologize, that should be equal to 0. I shouldn't leave that hanging there, huh? Okay, that's it. We're done. That's part 1. Okay. So we factored by GCF. We factored a perfect square trinomial. We see what that looks like. And then we factored when they weren't perfect square trinomials. Okay. What happens when this is no longer, the quadratic term is no longer a 1? Let's say it's a 5 or 6. How does that factor in? Well, you're going to see in part 2 of the video, so stay tuned. All right? Until next time, guys, have a good day.